Everybody is well. I hope everybody is going well and feeling good today. So the idea is to go down a topic, code, and the power of code. It's very crazy that as of today, we still are so little people learning how to code. So if you have anything, you open your mic and discuss about it. It's very, very open. We just want to exchange and have this community moment with you, talking about code, talking about life, talking about AI. Let's start. So if you don't know us, we are NAS. We are building an all-in-one open source data platform based on Jupyter notebooks. We have basically added microservices around the original Jupyter instance to make the notebooks production ready. And if you want to check us out, it's nas.ai, and you can create a free account on this platform. We are fully open source, and we are welcoming any kind of contribution. Our best stuff right now is the templates. We have a ton of templates in our GitHub repository, and any contributors are welcome to push new stuff, new templates, new notebook templates inside the open source platform. So let's start, and let's be very clear about what we are talking about today. We are talking about code and the criticality of code. So code is a really, really high sensitive decision-making process. It's a decision-making process. I want to strengthen that point because I have a story to tell, and it was in 2014. And at that point, we had the US had a problem with the 911 call. I think about 6,000 calls couldn't go through because a program that has been designed by a human hit a limit. It has hit a limit. So from that limit, they became aware that the program has run properly, but the code has not been designed properly. So it shows us how important code is and how important design in code is. Just a few numbers, but you have seen the post, so you know it now. There is only 0.5% people of the planet knowing how to code. So it's a crazy number. I don't know how if you guys are coming from code side or not code side, but it's very huge. And I think the story of code is about being closer to the people who don't know how to code, being closer to natural language. We're going to see that in the latest slide. So if we define a coder, it's someone who writes language for computers, aka machines. So the idea is, the central idea here, I think, is language. It's being able to talk to the machine, and it's the whole philosophy behind code. It's like being able to write and to tell to the machine in a nice way how the machine needs to react. So it's about languages. Obviously, it's about languages, programming languages. So what does code? How does code power the internet? We're going to cover that a bit, and what kind of word we can build with it, with all this new generation of AI called the transformers. We have talked about it in the post. We're going to cover this later during 20 minutes. So stay tuned, because we have a special guest coming in, and he's going to talk about this topic. A bit of history. I don't know if you guys knew, but the first computer is a loom. It was designed by Joseph-Marie Jacquard, a French guy, a French businessman. And he actually understood how to make this loom. And it is considered to be the first computer, because you got 0 and 1. You had the holes and you had stuff to fill. So it has been the first computer in the known history. So as a French guy and as a French team, we are kind of happy to see that, but it doesn't really mean anything right now. But it's always funny to see that it has a lot of history, computer and code. It dates back to the 1800. So it's kind of already more than 200 years. So nothing new here. A funny story as well. I don't know if you knew it, but fun fact: the people who were doing calculation at that time were called the computers, because they were computing calculations. So it's kind of very funny to see that we have still called the machine the computer. So basically we transform the humans making the calculation into the machines. And the guy that has actually transformed the loom, this idea of the loom into something that is close to a computer is Charles Babbage. He was a crazy guy in the UK in the 1830, and he was this guy who wanted to create the analytical engine. He called that the analytical engine. But he didn't really figure out how to finish this work. So he wanted to solve a lot of math problem with that, and he didn't really manage to do it. It's actually a woman called Ada Byron, a mathematician, that saw the power of this analytical machine, and she has really finished the job and seen how the power of this invention based on zeros and one. And she is describing in this text, which is quite fantastic, that she really understood how the analytical engine could apply not only to calculation, but to a lot of stuff. So she really realized that it can apply to music, to a lot of different stuff that can be brought to this analytical engine. So this is a bit of history. And then comes this guy, Morse, who has like literally came to invent the first way of communicating with zeros and ones. And so when we see that, then we can move to this guy called Alan Turing, and going very, very fast forward. Here is the moment where everything became very concrete, and Alan Turing used some kind of analytical engine to build the first known AI. He was a cryptograph. He helped the UK to decode the German message during the war. And it's the first moment where we saw the first level of AI. So I'm not a specialist in that. I just wanted to go back in time just to put this session into a quite good atmosphere where we know where we come from and what we're trying to do now. But it's kind of funny to just go back into the history and realize how this whole thing has been developed. Anybody has questions so far or wants to add something? It's good.
I just wanted, thank you, Jeremy, because you did quite a good presentation. I just wanted to mention Pascal, the French philosopher, who in fact, remember, he created a computing machine.
Yes.
And this computing machine worked. And in fact, he sold several copies. And these copies, there's still a copy or two around. That's all I wanted to say.
Yeah, exactly. And thank you for mentioning that. And hello, Denis. I was not expecting you that early, but I'm happy to see you here.
Yeah, because I saw your presentation and I thought it was excellent.
Excellent. I kind of like to, always go back in history because it makes a lot of sense to just come back to history, know where we come from.
Yeah.
Yeah, it's very important, I guess. And AI is not you. Alan Turing was here. He was the first guy who actually put the first AI in place. So as you always say, Denis, it's here it was already here. We just now understand better how to use it. So happy to see you here. For those who don't know, Denis is a super important author for me because he opened my eyes about the new generation of AI, the Transformers. He wrote a book about it, and we are going to talk about it a bit later during this office hour. So feel free, guys, if you want to open your mic and discuss with us. It's made for that. We are very open to conversation. And I have a lot of slides, but still we want to discuss and interact with all of you guys. So feel free to open your mic and ask questions. Let's keep going. So code basically is logic, right? It's the way to bring logic to a machine. And what is called algorithm is actually some kind of a logic that is applied to the machine. So it's very fancy, and everybody talks about algorithm and like this algorithm did this algorithm did that. We just need to come back to something very down to earth. If something happened, then something happened is an algorithm, and we are just getting to more complex algorithm years after years. But let's go back down to earth, like I said, and try to just not overthink so much, and just come back to real basics, because it always comes back to some very practical stuff that is all around us in the nature and everything. We have all this math and all this algorithm already existing in the nature. We're just trying to make sense of it. So here is it, algorithm, as simple as that. And the whole story is about finding the closest route to a destination. So why we do that, why we ask machine to do stuff, is because we human minds can just go in different like orders and go around and don't really go and find the straight line to find like to fix a problem. So I guess we are using machines to find what is the closest route, what is the closest journey to a destination. And AI is all about it. Dennis, you explain it also very well. One of the first thing we have touched when we spent a training session with you is this optimization of the closest route to a certain point. And I guess this is very representative of what code tries to do, like tries to find the closest way to fix a problem. So everything is about designing the closest route, but also the nicer code with the less amount of letters and text. So when you write code, you try to actually condense it to the essential way of reading, and being very minimalist in the way you approach code helps you to have a straight line, very clear to understand, and to also communicate to people. So I like this idea of finding the optimized way. It's about optimization, right? It's about finding the line that goes straight to your solution. But let's talk about it very frankly. Code is big power. So fusion bomb that was designed thanks to machines, thanks to computers, thanks to code. And what we can say is that the power of code amplifies the ability of people to do whatever they want to do. So it's not the technology that makes the human do certain way, it's the humans, right? So we need to make sure that when you code, what you code, you're responsible for it, and you understand the power that you have in your hands, because you do have power with the code. So yeah, it's all about zeros and one at the end of the day. We just told about it, but this is what the machine sees. And if we go back in time in history, what I see, and I think you can share, guys, what you see as well, Dennis and Tom. But the history of code has always been about like writing less one and zeros, basically, because we cannot do that as humans. So we need more power with less efforts. And this is the whole story about the programming language, and make code closest to the natural language is all about what the programming language has been, right? We always have been trying to find the most natural way to talk to machines. And today with NLP, AI, we are finally there. Like we are finally at this point where we will be soon enough able to talk to machines. So I guess it's a very exciting era we are living in. And I just wanted to also come back into this programming language era. Anybody wants to add something?
Yeah, I think you're really making a lot of progress in thinking. And what I like about your presentation is you've elevated the conversation, saying code. You're not talking Python, C++, Java functions. You're typically a French thinker of the tradition. where you bring concepts into the conversation. I like the concept of code and forget about the languages, but you're into what it does. And the second thing is interesting that you brought up is power. Code is power. Not many people will use that word associated with code, but code is power. So you've gone further. You've begun to introduce new concepts. Code is power. You're doing great.
Thanks, Denis.
I really agree, Jeremy. It's so great that you're starting from concepts and the growth of concepts that came out of history. Really appreciating that.
Yeah, I was always a big fan of history. Like back in the day, I wanted to be a history teacher, right? So this is always what I'm trying to understand the past to make sense of what's happening right now. So I'm happy you guys like it, and I guess that this presentation is all about bringing the foundation of what we want to build after, which is like helping people like getting into code, understanding what to do. So I think it was very important for us as a team at NAS to introduce this all of those concepts. So thank you guys. So what about programming language? Programming language is about abstraction. It's another concept that you guys need to have in mind. Low abstraction, high abstraction. So the story of code, as I've told, is always about like having less and less friction with the humans. So when you start with the hardware, you have the computer mechanics, which is the very basic zeros and one, and even like it's all the hardware. It's the way the component functions together. Then you have the binary. So this is the one and zeros. Then you have the assembly language, and it goes like this. It piles up to a high level abstraction, and basically binary, assembly language are all about like making code more closest to humans. So all this programming language, you have heard about it: Java, C++, JS, PHP, HTML, Python. I don't know how many coders we have in the room. I don't know if Valentin, we have known coders in the room, but if you do, just pick me about it. And because I guess that what we need to see is that among all those programming language, there is one programming language that goes heavy on the trend and adoption of whatever comes with the AI, and it's Python. So as you can see here, the growth of the different programming language shows very, very, very obviously that Python has been used more and more. And it's no surprise because this language is very, very easy to read, very easy to understand. And I will talk about myself, but as a known coder, I come from the business side. I don't know about code. I didn't know about code before getting stuck into my work. I was doing Excel VBA reports to my boss. I was working in treasury, cash management, and I didn't really know how to code. But then I realized that this language can unlock my problems, that automate my stuff, automate my work, and then automate basically the boring stuff I was doing to focus more on the use of my time, basically save time to be more with humans, to understand more humans' problem, to interact with my boss, to interact with everybody. So using code to write code to machines can help you save a crazy amount of time. And Python is the closest, for me, the closest way to go if you come from a non-technical side, to actually transform your skill set and add some more. So Python is definitely the language you need to check out. But then after this programming language, there is still a problem that we cannot address the people who don't know how to code. So we have this story of this guy, Douglas Engelbart, and he's part of this team in Palo Alto in the 70s that has invented what is called the GUI, the graphical user interface. And this guy actually invented one thing that you use every day, which is your mouse, the mouse of your computer. And those guys have invented this level of abstraction that helps everybody now use computers. So this is it. You have the whole level of abstraction. Well, there is one missing, but we are going to talk about it later on. It's machine learning. Let's wait a bit more before we deep dive into this subject. So GUI and the way that people now can use computers, use devices, is because we have GUIs. We have graphical user interface that enables a lot of people to use computers without knowing how to write 1 and 0s into the machines. So it's a big progress. And when we had that, at that time, 1970s, there was no internet yet. Internet was not so developed yet. And internet changed everything. Everything. Like literally everything. It connected everything. The world got connected together. And computers got connected together. So it changed everything because the whole world was now interconnected. And I think this is the big turning point in the history of code, where we see now people able to access information everywhere without having any other issue than just connecting to this network and ask the network to get return, which is the web page. So I wanted to deep dive into this and show you in 5 minutes, because we don't have so much time. We are already like 20 minutes, but I think we made it good so far in the presentation. But I want to go into some Q&A and questions and everything. So I just want to make it quick for you to understand, if you're not a coder, how internet works. So what we're going to do right now is I'm going to go and log into NAS, the NAS platform, which is a private server. And we are going to build a small website very, very quick. And this will help us understand how the whole thing works. We are going to use a NAS feature, which is called the asset feature. And we are going to see how we can expose a URL to the web with some HTML, CSS, and some Python. So are you ready, guys, for this live demo? I think this exercise is a bit hard, but I'm going to try it out. So I hope you stay with me on this, and let's build our website. So basically what you need to know, and we're going to come back about it, is like we have already a name server set up, NAS domain. I'm already connected to the internet right now, and we already have a server which is into AWS. We are just going to use files to build a website and show that it's very easy to build a website right now. All good? Are you guys always with me?
Super.
Cool?
Everyone
Okay,
is
cool.
very excited. Go.
Let's go. Okay. You can see my screen still? You have a full screen right now?
Yeah, we do.
All right, good. So I'm here on my NAS engine. So NAS is a Jupyter Lab instance. It's a server where you can have files and folders. It's basically like a computer, right? You have your computer, you have your folders. And what you can do is you can create notebooks. So what we want to do is we want to create a website. So to do that, what I'm going to do is I'm going to use a very simple domain. I don't know if you know about it. I always start with this example.com domain. So I have this website, okay? And this website is actually an HTML page. HTML stands for the text. The CSS is for the graphics, and the JS, the JavaScript, makes some animation. So we're just going to cover HTML and CSS. But first of all, if I want to do that, I have a few options. I can just go and save as example domain.html, okay? So I'm already having it on my computer, so I can download it. And if I download it and I just click on it, it opens it on my browser. So it means that this file that I just downloaded, the example domain, has actually a way to be rendered into my browser. So I want to download it and put it into my NAS. So I can either just drag and drop it here, but I can also use it for like basically get it out of the web with a small Python file. So what you want to do if you want to build a website is you want to type on the Google what you want to do. So I typed download a web page from Stack Overflow here, right? And I came to this this thing, Stack Overflow, which is a Q&A, and it's explaining me how to extract this website in Python. So I'm going to just do example.com and use this code as it is. And here it is. I have my HTML and I have my CSS right here under the style tag. So you can see it's basically tags. So all those tags are basically watched by your browser, and the browser now how to interpret it to render it into your environment. So now I have it here displayed, but I want to also save it on my file system here. So what I'm going to do is I'm going to also write into Google save HTML in Python. And I want to emphasize on the importance, I think, Dennis, you will follow me on this, on the importance of how to ask the machine. So what you are asking now is asking Google certain words, certain way of displaying the information, a certain kind of querying. It's like if you are asking someone a question, you need to ask a question in a certain way if you want to have the right answer. So one of the skills that is so underrated is how good are you to ask questions, and how good are you to use language to get your answers. So I think it's very important to understand this concept if you want to go into AI and NLP, and Dennis explained it very, very, very well in all his videos. So right now I copied this snippet of code. I want to use it as my site as HTML, and by displaying this, basically I have it here. Did I? I have it here. Sites.html. Right and close. Well, I think I have it here.
I guess you need to write the content. Where is the HTML content?
Oh, I have it here, exactly. I should have gone through the content, which is exactly this spot. So HTML.
Yes, HTML.
So write HTML. Here it is. Again. Here it is. I have downloaded my content, exactly. I've write my content, I have declared my website, and now I can use it here. So I have my website done. Okay, nice. And now how easy it is to just transform it into my domain. I can just do Jeremy's website. Okay. And just change a few stuff, right? I don't want to change so much, but I want to say it's Jeremy's website, and join me on social media. I just want to connect. If you want to connect with me, I'm just going to replace, because it's all about, like, you don't reinvent the wheel when you code. You just assemble stuff. You understand how things are done, and you want to assemble stuff together. So if I want to make a simple page to invite people to just join me, I just go like this. I will copy it, come back here, replace my profile, and I have it here. Jeremy's website, join me on social media, connect with me on LinkedIn. It is. I have my website, but I have it inside my NAS. I have it here. I have it here in my computer, in my virtual private server. So how do I expose it to the world? Well, I'm going just to use my Python notebook again, and I'm going to use a NAS formula that is going to expose this website to the world. So I'm going to use this formula called asset, and then I will declare that this site okay, will be HTML. And I want this to be, so let me check the doc. And I want this to be shown in my browser. So I don't want to download this thing. I'm going to use what is called the inline parameter right here. So I can open it inline. All right. Are you ready? Because, okay, nas.asset.add, create website. Oh, I made a mistake. I did create website.html. It doesn't exist, obviously. So I have an answer here saying to me, no, it's not the right stuff. You need to actually use the correct stuff. So you see how the machine is giving me feedback and everything. It's all about that. It's iteration. You learn, you test, you have errors, and now you try to fix what you want to do. So right here, I have my website. So now I'm going to share it with you. And here it is. You can just open it in your computer, and I've created a website. Now, the only thing I miss here is the way to map this actually asset name to a proper domain name like jeremyravnel.com. But you see how easy and simple people could understand how to use code and write code. And I think this kind of example shows a lot in how you don't have to know everything about the code. You need to know how to query or to search for the information you need, and you need to know how to assemble this thing into some element that you want to use. So I guess it's a good presentation. And coming back to this slide, so you understand now that everything is about building some files that are read by a server and written to your browser. It's all about this at the end of the day. This is how internet works. And it's millions of pages that are exposed to the world are now organized by the famous Google that everybody uses. But basically, it's all about that. And it's a little bit different when it's about emails, but websites are basically all about it. If you want to have some dynamic stuff, you can have JavaScript. It will enable to have pop-ups and what we call models. But at the end of the day, I guess everybody should know that at least they can do some kind of website like this. And if I had the opportunity to know that before, I would have been probably a coder sooner, because nobody teach you that in school here in France. So I guess it's important to start back from this. If you guys have questions or any comments, it's open. So what do you think? Do you think it's a cool explanation of how internet works? Do you have questions?
Yeah, good explanation.
Cool. Thank you very much. Anybody in the comments, feel free to just come back to it. So let's jump back into this presentation, because we made it in 5 minutes, and it's as simple as that. If you want to deep dive into NAS and the features, just go into docs.nas.ai. We have a scheduler. I know, Gilbert, we were talking about the scheduler. You can just use the scheduler inside a notebook with this. And basically, as you understood, notebooks are really an interface, a document where you can write text, you can write code. If you want to make it nicely, you can just use Markdown to create a website. And just to finish about like what we do at NAS, you can actually go and figure out our templates. When you have your account created, you can go in our templates, and I will probably push this one to the repository. We have on GitHub everything exposed and also accessible here. If you want to get, for example, your LinkedIn followers, you can just use our library of templates, and by just clicking here on Open in NAS, you will be able to download these templates to your NAS engine. And And if you want to go into our GitHub, we are Jupyter NAS. It's right here. Awesome notebook. And you will be able to see everything that we've been working on. It's also accessible from here directly. We don't need to connect. It's all open source. And you'll be able to see the notebook from here. Here it is. Maybe a thing is what is important also is structure your notebooks, structure your code in a certain way. Here we are trying to put everything under a framework, which is the input, model, and output framework. I'm going to talk about it right now because it resonates with what machine learning and AI is all about. So let's keep going. Valentin, you tell me if you have any question, if there is any question in the chat or everything. I hope there is some at the end where I hope we can do some Q&A.
Yeah, I think we will do this session right after, but we don't have a question right now.
Okay, cool. So Facebook exploded and showed that the internet was going to be big. I don't know, you all have a Facebook account probably. And it really showed that the world is going to be completely changed at this moment of time where social media entered the game. So we have an amount of data that has been exploding thanks to social media or because of social media. And this is now what fuels AI. So I guess Denis will talk about it right after. So programming is the art of being exhaustive in taking into account different possible conditions for solving a problem. I just wanted to state that as well. And let's go into machine learning, because machine learning is a higher level of abstraction, and it's all about this idea where before we were having an input, we were having an output, and someone had to code to basically create the output now and code the model. So now with machine learning, you don't really have to code everything inside this space. The machine has already figured out a way to go to the destination. And this is how powerful machine learning is. It's actually about not having to code the model in between your input and your output. And it's talking directly to the computer mechanics. It's talking directly to the hardware. So machine learning is directly connected to the computer. It's directly transforming what you intend to do into one and zeros. And I think this is how powerful this technology is and this kind of abstraction is. So machine learning. Machine learning is about recognizing stuff. Here is the party, not a party, but it's about much more than that. And this is where I'm going to call to the stage Mr. Denis Rodman about the transformers, because he has written a book about it, and it's very, very interesting to have his view on this. Transformer or the next generation of AI. So Denis, my question to you is how transformers models are changing the game of AI as of now. When we speak, what have they done? Where are they? Why are they bringing so much difference into the AI space?
Well, thank you first for your high-level presentation, because in fact, you brought a lot of concepts into the discussion. So let's go back to what you said. First, we have reality. That's what you're doing, NASA's doing, I'm doing, other people are doing. On top of that, let's go to your next concept. We use code, and let's take this HTML code to build a layer over. We're building a layer over our reality. So it's not reality anymore. It's in semiology or linguistics, it's a hyper-reality. It's something we're going to live in. We're not going to live in the reality anymore. We're going to live in this hyper-reality you created with your frictionless HTML page. And this gives you now the power that you were speaking about. You put forward all the concepts. It's giving you the power now to influence people and give them the information you want. On top of, so right at that point, you have billions upon billions and billions and billions of pieces of information that are popping up from all over the world in Facebook, LinkedIn, YouTube, corporate side, science, all that's up there. And then I'll introduce a new high-level thing of abstraction, the way you talk, is a map. Somehow Google needs to map that information so that when we're looking into this hyper reality, we have to find the information we want somewhere.
Exactly.
We don't know the map. We don't see the map. The map is invisible to us. So we're trying to figure out what we can tell Google so that Google can answer and give us something that brings us to this hyper reality and back to our reality. So where do transformers come in? Transformers are a two-sided coin. Transformers will take all of those billions of pieces of information, and they will not do recurrent neural network sequence analysis anymore. They're going to compare everything to everything, every word to every other word, every sequence to every other sequence. And what is extremely new is the power, the number of parameters, like 175 billion in a GPT-3
Exactly.
transformer model, and the scale, the huge computer power. So what's happening now is, this is a key word I would add just above your abstraction level, the way you express things, is emergence. Emergence is when you enter the theory of complexity. It's more than the sum of parts. It means that transformers produce engines that can do things it wasn't trained for. In fact, nobody knows exactly what a GPT-3 engine can do. You have to find out. You can explore it like Christopher Columbus. Even OpenAI doesn't know it. Google BERT is the equivalent of GPT-3. No one knows what it can do. So that's this two-sided coin. It means if you don't know how to write a prompt, it's prompt engineering, when you're looking for something on Google, then you don't know what's going to happen. So most of the time, people will start 1, 2, 3, 4 times. They'll change the search. No, that's not what I want. No, that's not what I want. No, that's not what I want. Then you scroll your pages and you waste a lot of time. So it's an emergent technology. So I've been doing this, for example, with my friends and family. When I watch them, I say, hey, why don't you write this? Write this. And they say, gee, I got what I want immediately. So you have to understand that it's the way you said, it's frictionless. You can express yourself in your own language and you'll get what you want. Okay, so that's emergence. And then you have homogenization. That means it can do anything, semantic search or anything, all these tasks. Now
I have all this list of tasks that I put into the slide, which is crazy. I have the access to OpenAI as well as you do, I'm sure.
Yeah, but that's just 40 tasks. That's just 40 tasks. I can find 1,000 other tasks. I've been inventing tasks every day. I just invent tasks every day. Now, we're going to go back to our two-sided coin. Remember I told you it's a two-sided coin?
Yeah.
We only did heads. Now we're going to do tails. That's the bad part. The good part is the heads. Do anything you want. It's emergence and everything. Tails is the other part. We go back to another person I can introduce in your presentation, is George Luis Borges, an Argentine writer. And he said, sure, one day in this empire, someone created a map so big that it covered the whole empire. So now we can only see the empire through this map. So what's happening on the other side of the coin is we only see the world through Google's map. It's Google's maps. So you can type anything you want. You can show me those pictures, but those are only the pictures that Google wants you to see. It's like someone that's doing a card trick in front of you. He says, choose a card. You're free to choose a card. You know that you're going to choose the card he wants you to choose. So it's the other side of the coin is that there's a policy in all these search engines that they created the maps. So you can only see the world through this hyper reality. You'll never see what you really want to see. You can try sometimes, but you won't reach it. If they decide you won't see it, you won't see it. Even on LinkedIn, if you write a post that they don't like, it'll go to the bottom. So they have all these search keywords and all that. So on one hand, it's so big and emergent that you can invent any kind of task. On the other side, what are you inventing the tasks for in Google search is to look into a map. But the map wasn't built by you. So you can use anything you want to invent. You have to go into a mind frame, a mindset. You have to have a certain way of thinking to get it. So there's two things you have to learn. You have to learn the prompt engineering, how am I going to write it? And to do that, you have to go back to what you just showed, do all these exercises. They have all these examples in the playground. But on the other hand, you have to understand how that map was built. And you're going to only understand that by exploring different ways of searching. So once you've acquired this way of emergent technology, or you're inventing your own tasks on Google, you can do functions, you can do anything you want. It's incredible the amount of things you can do. But on the other side, you know that there's a map. So you only can see the guards they put in the deck. So you have to think, you have to find a way to figure out how they made that map. And then you have to find the keyhole. It's Plato's cave. You have to find your own way to the light. And sometimes I do searches, and I'm doing searches to find that little keyhole, something they've forgotten in the map, and then get to the map and get to that secret door. And from that secret door, open my door to information. Things they don't see. They don't see, for example, I'll give you things I like to do. They don't see in a lot of scientific papers. They scan them, they do it, but there's a meaning, but it's not that deep. So you can find keyholes and get to freedom, to other ways of thinking. So it's a two-sided coin. So what you have to remember is the key word here, the takeaway is emergence. It's so big that it trains to do things that no one knows why it trained to do it. It's training things it wasn't trained for, and new things emerge. And it's becoming something that Aristotle said, he didn't really say it, we all say it, but it's a misquote, but it's a true concept, that the whole is bigger than the sum of its parts. It's something else. We don't know what it is. So transformers have completely changed the world. We're in a post-deep learning era now with this kind of emergent models. So those are the two sides, and my message is if you don't know how to use them, they'll use you.
Yeah, that's the whole point. And I think that's the whole story about how we are all like also fascinated about that. It's like how to actually understand how to use transformers and AI to the best and to our advantage at one point. So everybody's like trying to win this battle and figure out.
Jeremy?
Yeah.
Would it be okay if I quoted something from a good transformer book I recently read?
Yeah.
It's not really a quote, but and I can't say the author's name, but his initials are Dennis Rothman. I was relieved when he pointed out, look, if you're going to train for a specific task, you can take this tiny transformer model that's, what, Dennis, I think it was 1,000th or 10,000th the size of GPT-3, and it'll still kick GPT-3's butt, and you can train it on a normal human-owned PC, single human-owned PC that has a good GPU in 24 hours. And I was so afraid when GPT-3 came out. I thought this is the end of AI democratization. But what's fascinating is with just some decent hardware, you can still get great performance with a reasonably sized model. And that was a big revelation in Dennis's book.
That's very reassuring.
Thank you, Tom.
That's really reassuring, because I wanted to just point out that when you have access to this kind of OpenAI GPT-3, so we are right here into GPT-3, you have so many tasks that you can do, and you can have conversation. And what you're talking about, Dennis, is about prompt engineering, and it's something that I didn't know before. But you need to design a certain way the questions. So
now there's a trick. There's a trick I found a few weeks ago, because I spend a lot of time. I have a lot of fun playing around with it, even on my smartphone, watching TV and all that. So I found a way to influence it. I found a way to make it change culturally, and I did it through a feature they made available is fine-tuning the GPT-3 engine. You can do that now. So what I did, because I'm a great fan of Immanuel Kant, the German philosopher, and I said, what if because I like philosophy, and I like belief. I like things that are not material. I like concepts like God. I like that. So I was saying this thing is too pragmatic and all that. So I took all of the works of Immanuel Kant, I processed them, I put them in a text file, and I just fed it into a GPT-3 engine for fine tuning, and it fine tuned it to think like Kant. So now I turned it into from a disbeliever into a believer. So I'm saying, so I was like, I was saying, what is the core of humans? And then the GPT-3 engine will answer, well, it's thought, it's the belief in God and all that. So I say, gee, I'm influencing the system. So it goes back to what Tom is saying. And what I was saying, you can find your secret door to what you want. You can influence it with prompt engineering, and you can also fine tune it, and you can also build your little model. In fact, I put two models side to side in chapter like 3 of the book. I put Kant in there, and I was having fun with it. And then I did it with GPT-3, and I compared the two.
The results.
Both results, and I found if you really fine tune a small model, you can get to the same result. So it's up to you.
Nice. So it's very encouraging what you're saying, guys, because as practitioners, you guys, Tom and Dennis, basically what you're saying is that at one point we could train our own AI based on our own creations. Like if I create text, if I create material that is out of my brain, and if I kind of write everything that I think, at one point all my material could be synthesized and like understood, and they could actually discuss, even if I'm dead, they could actually discuss with me because of all my writings
with the proper prompt engineering.
With the proper prompt engineering, that's very encouraging. It means that at one point AI can actually be democratized, and people could build their own.
And Jeremy, to add more encouragement to lean on what Dennis has been saying, I find it frustrating I can't get a hold of GPT-3 personally, at least through the means that I want to. But with a little more effort, I can transfer teach, or GPT-2 can transfer learn from what I want it to do. You'll see in the publications, what Dennis is talking about is transfer learning or transfer teaching, I like to call it, because we're teaching it. We're giving it, no, I don't want you to answer that way. I want you to answer this way. And over time, it will start to lean toward that new influence. But GPT-2 is available in various sizes and still pretty darn good. And it's pre-trained. So you can take that. It's like it's a graduate from high school.
Yeah.
Now I'm going to give you some on-the-job training. That's what's exciting.
Very cool. And I would like to also make a big shout out to a team of French guys called the Hugging Face team that are actually making all this thing open source, and they are doing a fantastic job in this. So I think, yeah, there is a lot of interesting stuff to do, and we have a few templates on Hugging Face. I've recently done an exercise with the contributor where he actually designed some kind of a notebook where you can ask if an idea is environmentally friendly, yes or no. And he's just answering Boolean question like this, like, is it good to buy an iPhone, yes or no? So I think it's kind of funny how all this thing can be designed, even because GPT-3, so you can guys understand, GPT-3 is now private and is in the hands of Microsoft. And BERT, which is another transformer model, is in the end of Google. I don't know about Amazon.
Yeah, that's important.
Yeah.
Google search is based on Google BERT, which is as powerful as GPT-3. So in fact, you can have a lot of fun in Google search. I'm doing a lot of things with Google search that Google search wasn't made for at all, because I told you about emergence. Yeah. So I'm having a great time, like solving a triangle equation. You could try it. There are a lot of loopholes in there. It's back like in the 80s where you can go through a back door and do what you want with it. So you can have a lot of fun with Google BERT. on Google
and
search.
you made a nice video on your YouTube channel about it. I watched it and I thought it was very funny to see. So yeah, very good. And so for those who wants to concretely see what a prompt is, it's basically, so we are here into OpenAI, and so it's just basically a text where you can just submit and get some question and answer from the AI. So there is summarized text for second graders. So if we take what is the meaning of life, I don't know, we have a text in Google here. We can just paste it back down in here and see what the AI is doing. Overloaded with requests. Okay. All right. So, I just copy pasted a text that I found in Google. What is the meaning of life?
GPT-3 is overloaded right now.
Yeah.
But do your same experience with Google search. Say, summarize the meaning of life for me. Summarize the meaning of life for me in a few words. Type it up there instead of typing it in GPT-3 as a prompt. Summarize the meaning of life for
in one
a
sentence?
school child in a few lines. You'll see, you'll get the same result. I've been doing it all the time. It's a lot of fun. I think, that's what I showed, something like that in the video.
Yeah, you showed something like this.
You can do exactly what you're doing in GPT-3 with Google Bird on Google Search.
Because it's the same concept. It's a transformer model.
It's emergent.
Yeah,
they don't know what they built. They don't control it. That's, for the moment, they can't control it. So you can do a lot of things with it.
Do you think they will control it and put more? Yeah, they will.
Yeah, the power. Remember what you said?
Yeah.
Your concepts are powerful. Code is power. Power is money. Money is marketing. So of course.
But maybe get a copy. Maybe get a copy before they take the freedom of it away.
Yeah. Anybody ask questions? Because we are already over time, and I don't want you guys to just. What do you think? I would like you guys can open your mic and just think, tell us what you thought about this session, and if you liked it, just put. If you don't want to talk, just put thumbs up or thumbs down. I would be very happy to have your feedbacks and connect with all of you guys. Thank you, Tom, for being here. Guys, it has been a very interesting session, and I'm very happy to have spent this time with you. We will be here every Thursday, so feel free to join. We'll go deeper into NAS because we have seen today how to use the asset feature, and we will just do more with the scheduler, the webhook, and all those features we have designed. We will talk about open source. We will talk about how to contribute to open source, how to use GitHub, and a lot of nice topics are going to be on the table in the future session. So you're all welcome to join. And this first session has been really fun. Thank you, Dennis, for joining and putting your knowledge with us and sharing your knowledge with us. It has been a wonderful moment. Anybody wants to add something? Chris?
Yeah, I just wanted to briefly say that I think this is an amazing kickoff to what seems like will be a fun weekly gathering of like minds. As the data space continues to proliferate the way that it is right now, I think it's important to have these type of spaces where we can come together and talk across the spectrum of background and technical experience, and kind of come together and have this shared type of experience. And so this is extremely exciting. So thank you, Jeremy, for putting this together.
Thank you.
I'm looking forward to participating.
Hey, Jeremy, you might want to get Ugo to talk.
Ugo, are you here?
Ugo? Yeah, look for him. He's somewhere here. He's hiding somewhere. And believe me, he's a rising thinker. He is a fantastic thinker. Find him there, Ugo. Ugo, where are you? I know you're here. I'm sure you're here.
Yeah, he is here.
He is here. Get him to talk. He is the thinker. He's thinking so much, and I really love the way he writes posts on LinkedIn.
Hugo, how are you?
Thank you. I'm fine, Jeremy. Thank you, Dennis. Today's my birthday, so I'm just
okay. Happy birthday, Hugo.
Happy birthday, Hugo.
Happy birthday, Hugo.
Thank you.
Birthday.
Hugo,
Thank
you need to talk. You need to express your ideas.
Well, funny enough, I joined very late. I had another session, a couple of meetings here and there. I guess they've not even allowed me to celebrate my birthday, so
happy birthday.
Thank you. So I joined pretty late. I didn't quite get the flow of the conversation. I mean, I've been in the room.
There's going to be a replay. Everything is going to be on YouTube. All the sessions are going to be recorded and shared.
But Jeremy, get Hugo to talk.
Yeah, I would definitely.
He is a great thinker. He is a thinker.
Yeah. I would definitely want to connect more with you, Hugo. And,
I'm grateful.
And I'm happy to see all of those comments. Also, everybody seems to be quite happy with this session. So I won't take more of your time today, guys. I guess it was a nice way to kickstart. I wanted to really come back to the basics, come back to the history, explain what code is, the power of code, all those concepts that will serve, and we can build on top of those concepts new stuff. And hopefully you can enjoy using NAS as an open source tool to build with your notebooks stuff you want to do. The platform, the idea of NAS is really to be able to have your own engine, your own data engine, your automation engine. So, get it. It's free, and you can just log in, try a few stuff, and let us know what you think. We are building this with the community. We have a Slack channel also, the NAS Club. So feel free to come and join, and we'll be happy to talk with you. All of the team here is really eager to learn more about this community around data, automation, AI. So thank you so much. The link is here, Valentin's just shared. Thank you so much, Dennis, for coming and joining this session with us. And have a wonderful Thursday and enjoy the rest of your day, everybody. See you.
Thank you, everyone. Thank you, Jeremy.
Thank you.
Thank you,
Thank
Dennis.
you.
Thank you,
Bye.
Jeremy.
Bye.
Thank you, Dennis.
Thank you, Jeremy.
Thank you, Jeremy.
Bye-bye.
Bye.